appear question five. We are asked to find the transfer function of this circle. And we all know that the transfer function of this circle is brought to the Laplace of the circle. That's b to the output source over the input.
Okay, so this element is a number by 3. Looking at the diagram given to the circuit, can identify some components in the circuit that's two capacitors and two inductors. Now, looking at this circuit, how are we going to implement it to get the transfer function? You can see that from this circuit, we are having two nodes, intermediary nodes. That's where all the components going. So we can identify this node here, this first node. Let's name it as B or node A. And you can also identify a node here, which is node B. But you have to be careful in naming this node because we know that this node here is the output source. That's B2. So this node here will be the B2 node. Now, looking at this circuit, you know that this is the input source coming all the way from that side, and this is the node here. So looking at finding the voltage drop here, we know that in order to find the current passing through this capacitor, we are seeing two voltage sources. So in order to find the current passing through this, we know that current 2 will be equal to V over R. So identifying the current passing through here and noticing that there are two sources here, that means you're going to find the voltage difference over the R, but in this case it's not an R, it's the capacitor. So that's it. Now that's for this one. Now we also have to identify the current moving from this side to the inductor. Moving from this side to the inductor. That's also one thing. And now the current moving from this side to the capacitor or the second capacitor. Now, we also have to be careful once again because for the second capacitor, we are finding a voltage source here, but we also established a node at this point that's making two voltage sources. Now, in order to find the current passing through here, we are supposed to find the difference in the voltage source over the capacitor, and we are able to find it. Now, that's for all current living at the VA. That's what we're going to do. So in this circuit that we are having here, as I said, identifying two nodes to solve this example. Thank you very much.
I am proof all very explained, and as already explained by my colleague, important to know that the transfer function is the Laplace of the output over the input. And then we see from our circuit that we have a capacitor, we have an inductor here. So we are supposed to convert this, which is in the time domain, to the frequency domain. And then the only thing that can help us is to move this to the Laplace domain. So now, considering this, at this root, the current flowing through this capacitor can be expressed as I of C in the time domain is equal to C dV all over dt. So now, moving it to the Laplace domain, which is the frequency domain, this I of C moves to the Laplace domain, and we get I of C of S, and then we get C bracket open S B of S, and then we set the initial condition to 0. So if we are setting the initial condition to 0, we would arrive at this, and then rearranging the equation in terms of Vs over Is, we would arrive at 1 over SC, which is the Laplace of the capacitor Thank you.
I am listening to Jason and working in the time domain inductor. This is the time domain for this situation. Now I'm working on moving this from the time to the frequency, that is getting the Laplace. So we are going to be working for Laplace on both sides. So that is for this. So working for Laplace on both sides, I'm going to be getting this equation. Now we know that for this we are going to be setting it to 0. That's it. Assuming 0 initial conditions. So for this we are going to set it to 0. And you're going to retain V of L is B over I, that is LS, being equal to SL. So we know that for the inductor, we're going to be getting Z of L being equal to S capital of L. Thank you.
According to Kirchhoff's current law, taking the KCL at node A, we will have our first equation to be VA minus V1 all over the resistance. In this case, we have a capacitive reactance, so we are going to be taking the Laplace of the impedance from the capacitor, which is 1 over x. So 1 over x, then plus. From this same root, we'll be having VA minus V2 all over the same capacitive reactance, which is 1 over x, expressed in Laplace form, then plus this side, so VA over. In this case, we have an inductor here, so we are going to be taking the inductive reactance and then taking the Laplace of that, we have it as x. And then, according to Kirchhoff's current law, you are supposed to equate all of these two. They should all sum up to 0. So, simplifying this, we have S over VA minus V1 plus S into bracket VA minus V2 plus VA over S is equal to 0. So, simplifying this, if we do the algebra, and you are done with everything, you should be getting VA into bracket S2 plus 1 is equal to S2 into bracket V1 plus V2. Thank you.
This is going to ground. So here we come to you have to break down the formula first, which is V2 over S is equal to the inductive impedance. Then V2 minus the VA over 1 over S is equal to the current capacitor impedance. Applying the Kirchhoff's law, which says that on the algebraic sum of all currents leaving the node is equal to 0. Leaving the current is equal to 0. So we combine the two formulas together, the two equations together. Then when we simplify, we get V2 over S plus S to V2 over V2 minus VA is equal to 0. Then here you come here, you multiply V2 plus S to the power use the V2 minus VA. So you multiply everything in the bracket, and then you expand it, so when it multiplies all of them, that's what you get. Then the final answer, which you get, the VA is equal to V2 over S2 plus 1 over 4S.
My name is Desmond Appiah, and I'll be taking us through the equations on how we go the transfer function. So comparing the two profiles, we have V of A equal to S, and that's the expression of that A. So we are going to cross multiply this expression, giving us this information. When we cross multiply, we are going to get this. So from here, we are going to multiply these two brackets. We are going to expand this bracket at the right hand side. So after expanding, we have a solution to be 2S. That's the 2S is going to 4 plus 2S squared equals 1. This is going to multiply the roots of as we are doing. So now let's expand the brackets and the left hand side. We are going to get S is going to 4 equating to today's expression. Yes. So now you are going to collect the terms of V2. But in collecting the terms of V2, we have to move S is going to 4 to this side. Making S is going to 4 V1 the same thing. We are going to get it's going to equate to V2. What's our expression? 2S squared plus 2S squared plus 1 minus S is going to 4. Then the calculation, I'm going to get S is going to 4 V1 equals to V2. Apply the expression, S is going to 4 plus 3S squared plus 1. So in getting the transfer function, we know that V2 over V1 is going to give us the transfer function here times.
My name is Mrs. Marianne, and I'll be taking us through the sample of the question we were asked to solve. So for our circuit, we were asked to find the transfer function of the circuit. In our circuit, we can clearly see that there are two capacitors and two inductors, as well as two voltage sources. Now we know that the transfer function is the Laplace of the output voltage to the Laplace of the input voltage. So at the end of the day, we are looking for our output to be V2 over V1. Now, because we are dealing with Laplace, we have to represent our capacitors and inductors in the frequency domain, which is the Laplace. In doing so, we find our capacitor to be 1 over Cs and our inductors to be SL. In the question, we are giving our capacitance and inductance to be 1 each. Substituting them into the equations or functions we have, we arrive with our C being equal to 1 over S, that's our capacitance in the frequency domain, and our inductance to be S in the frequency domain as well. So applying Kirchhoff's law in this first as a result of the nodes that are found in the circuit, which is node VA and node V. We are taking Kirchhoff's law at node VA. In doing so, we come across this function that says VA minus V1 over 1 by S, that is the voltage at the node minus the input voltage divided by capacitance in the Laplace form plus the voltage VA minus the voltage V2 over the second capacitance here plus our VA over S, which is the inductance. Simplifying, we come across this expression. And finally, for this node, our VA sums up to S squared V1 plus V2 all over 2S squared plus 1.
So please, my name is Jessica and I'll be taking us through the whole idea of what you will have to be. So taking the B, so like this which is the CL, taking the B, so we have a capacitor here, we have our inductance right here. So these are the ones that are taken from the B, and from applying the sheets we learned about currents, even they are all equal to 0. So over here, everything represents I. Everything is represents I. And when the I is equal to 1, sorry, I is equal to V over R. Yes. So here is the unit of everything. So this one represents V is equal to S, it's representing an inductor impedance, which is evaluated. We had this from ZL. V2 minus VA. V2 is going to be side. We know that from here, VA is supplying to C. V2 is supplying to C as well. So it's V2 minus VA all over what we have at this side. So apply this here. Everything has to be equal to 0. And we simplify everything and expand. We're going to get our VAA, our VAB, which is like taking VA from V. We are going to get it to be V2. That is S squared plus 1, and that is okay, so moving forward, we're now going to compare the load voltages. Comparing VA that we have taking respect to node A, VA that we have with respect to the B. So when we're comparing these two, we know that this is what we have from node A, and this is what we have from node B. So we're going to compare the two, and we're going to make V2 over V1 the subject. We know that for finding transfer functions, we know that it's the Laplace of the output over the Laplace of the input. So when I'm checking all those things, we're going to have S4, we're going to have this equation. So all in all, we're going to make V2 over V1 the subject of everything. That's to make sure to expand everything so that you'll be able to get single V2 over single V1. And after everything, we're going to get our V2 over V1 to be S raised to the power 4 over S raised to the power 4 plus 3x squared plus 1.
Thank you.